Have you ever just stopped and thought about all of the chemistry that's happening around you, like all the time? It's hidden in the most ordinary parts of your day. From cooking food to just using stuff, things are constantly changing. And it turns out, if you can understand the simple difference between a physical change and a chemical change, you'll start to see the world in a completely new way. So let's kick things off with a question you've probably wondered about. Right. That super bright, whiter than white smile, what's actually going on there? Are we just kind of scraping the stains off the surface, or is it something a little more chemical? This one question is going to be our guide as we dive into the really fundamental science of change. Okay, so to get our answer, we first have to look at the two main ways people get their teeth whiter. And it turns out both methods are out there, but they work in totally different ways. So on one side, you've got surface whitening. The best way to think about this is a physical job. You're using something abrasive like baking soda to literally scrub and polish stains off the surface. But on the other side, you've got bleaching. This uses a reactive chemical like hydrogen peroxide. So one is a scrape and the other is a reaction. And to really get why that difference is so important, we need to lay down some ground rules. Before we can even talk about things changing, we first got to understand their properties. You know, a property is just a way to describe what a substance is like, its basic characteristics. And, as we're about to see, they come in two main flavors. So first up is a physical property. This is basically any characteristic you can see or measure without actually changing what the substance is. It's all about describing the identity of a substance, not transforming it. For example, we're talking about things like color, texture, density, smell, even its melting point. You know, when you say water is clear or that an ice cube is solid, you haven't changed the fact that it's still H2O, you're just describing its physical properties. Now, let's contrast that with a chemical property. This isn't about what a substance is right now, but what it could become. It describes its potential to go through a change that turns it into something totally new. So think about flammability. The fact that a piece of wood can burn is a chemical property. You only really see that property in action when the wood is actively changing into ash and smoke and gas. And hey, check out that third one, bleaching ability. The potential for a substance to break down color, well, that's a core chemical property. And that gets us one step closer to solving our teeth whitening mystery. Okay, so we've got properties. They describe what something is like. Now let's move on to the next piece of this puzzle, changes. Changes describe what something is doing. I love this analogy. It's such a great way to think about it. A property is like an adjective. It describes the substance, yellow, heavy, solid. But a change? That's the verb. It's the action word, melting, burning, dissolving. It's all about what the substance is doing. And just like properties, changes come in two types. So first, you've got a physical change. This is any change that just messes with the form or appearance of something. But, and this is key, it does not create a new substance. If you tear paper, it's still paper. If you melt an ice cube, it's still water. Now, some physical changes you can undo, right? They're reversible. You can melt ice and then freeze it right back. But some are irreversible. I mean, once you cut a log into lumber, you can't really uncut it. But the crucial thing here is that the wood is still wood. Nothing new has been created. And then you have the chemical change. This is also called a chemical reaction. And this is the big one. This is when a substance actually transforms into one or more totally new substances with totally different properties. A chemical change makes something new. So, this brings us all the way back to our smile. Now that we have our definitions, we can solve the mystery. Surface whitening, just scraping off stains, that's a physical change. The tooth underneath is still a tooth. But bleaching, using hydrogen peroxide to break down the actual stain molecules, that, my friends, is a chemical change. A new, colorless substance is formed right where that old coffee stain used to be. All right, so now that we know what a chemical change actually is, how can we spot one happening out in the wild? Well, luckily for us, there are a few telltale clues to look out for. For instance, if a new color just appears out of nowhere, like when silver tarnishes, that's a good sign. Or if you see bubbles of gas forming. Same goes for heat or light being produced. Think of a fire. Or a change that's just really, really hard to reverse. You can't uncook an egg, right? But, and this is super important, these are just clues. They're not definitive proof. Think about it. Boiling water makes bubbles, but that's a physical change, right? It's just liquid water turning into water vapor. But mixing baking soda and vinegar also makes bubbles, and that's a full-on chemical reaction. So the only way to be 100% sure is to actually test what you're left with and see if it's different from what you started with. Now, you might be thinking, okay, this is interesting science, but why does this really matter in my life? Well, it turns out that understanding this difference has massive real-world consequences, especially for our environment. And it all kind of starts with the old batteries in your junk drawer. So, while a lot of chemical changes are tough to undo, some are actually designed to be reversible. And that's the whole secret behind rechargeable batteries. It's just a reversible chemical change. As you use the battery, one reaction happens and gives you electricity, and when you plug it in to recharge, you're just forcing that reaction to run backwards. And this is where it gets really serious. When these old rechargeable batteries get thrown in the regular trash, they become a huge environmental problem. In fact, it's estimated that over 50% of one particularly toxic chemical in our landfills comes from just one source: improperly discarded batteries. That chemical is called cadmium, and it's found in those old NiCad batteries. And this stuff is incredibly dangerous. We're talking about a highly toxic pollutant, a known carcinogen, and it's linked to all sorts of serious health problems. But the worst part, it can't be broken down into anything safer. Once it gets out into the environment, it is there for good. So what can you actually do? Well, this knowledge is power. First, search your house for any old battery-powered gadgets. Old laptops, cordless phones, power tools. Second, check the battery for that little NICD symbol. And third, if you find one, please don't just toss it in the bin. Take it to a proper recycling center or a hazardous waste depot. It's such a simple action, but it makes a world of difference. We started this journey with a simple question about a smile, and we ended it by talking about the fate of toxic chemicals in our environment. This distinction between physical and chemical changes, it's literally everywhere. It's the nail rusting on a fence. It's the food you're digesting right now. So I'll just leave you with this question to chew on. Now that you know the clues, what invisible chemical reactions are happening all around you, right at this very moment?